Good morning, children. Today, in Surface Areas and Volumes Part 3, we are going to study volume of combinations of solids. Volume of a combination of solids. Volume of a solid formed by joining two basic solid shapes will be the sum of the volume of the solids separately. Let us start with exercise 13.2 from our textbook. Question number 1. A solid is in the shape of a cone, standing on a hemisphere, with both their radii being equal to 1 cm, and the height of the cone is equal to the radius. Find the volume of the solid in terms of pi. We can see the figure a hemisphere and a cone on the top of the hemisphere. It is given that both the radii are equal to 1 cm. Therefore, we can write radius of the cone is equal to 1 cm and radius of the hemisphere also is equal to 1 cm. It is given height of the cone is equal to the radius. Therefore, height of the cone is also 1 cm. To find the volume of the solid, we can see it will be volume of the cone plus volume of the hemisphere. Volume of the cone is 1 by 3 pi r square h and volume of the hemisphere is 2 by 3 pi r cube. Taking 1 by 3 and pi r square common, we can see it will be 1 by 3 pi r square into h plus 2r. Substituting the values, radius equal to 1, height is also equal to 1. We have 1 by 3 pi into 1 square multiplied with 1 plus 2 into 1. That is 1 by 3 pi into 1 into 3, which is equal to pi centimeter cube. In question number 2, we can see Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminium sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rachel made. We can see the model is in the shape of a cylinder and two cones attached to it. It is given diameter is equal to 3 cm. So, diameter of the cylinder as well as diameter of the cone will be 3 cm, and we can say radius of the cylinder will be 1.5 cm and radius of the cone also will be 1.5 cm. Now it is given the length of the model is 12 cm. As the radius of the cone is 1.5 cm and height of the cone is 2 cm, we can say height of the cylinder will be 12 minus of 2 plus 2, which is equal to 8 cm. To find the volume of air contained in the model, we can say it will be volume of the cylinder plus 2 times volume of the cone. Substituting the formulas, it will be pi r square h plus 2 into 1 by 3 pi r square h. We know the height of the cylinder and height of the cone are different. Therefore, we can show height of the cylinder with capital H and height of the cone with small letter h. Radius being same, common factor pi r square into h plus 2 by 3 h. Radius is equal to 1.5, otherwise 3 by 2. Height of the cylinder is 8 and height of the cone is 2. Substituting the values, it will be 22 by 7 into 3 by 2 whole square multiplied with 8 plus 4 by 3, which can be written as 22 by 7 into 3 by 2 into 3 by 2 into 28 by 3. After cancellation, the answer will be 66 centimeter cube. In question number 3, a gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and diameter 2.8 cm. Here, the gulab jamun is in the shape of a cylinder with two hemispheres on both of its ends. And we are given the total length of the gulab jamun is 5 cm and diameter of the hemisphere is 2.8 cm. So we can say radius of the hemisphere as well as radius of the cylinder will be 2.8 divided by 2, which is equal to 1.4 cm. Now for finding the height of the cylinder, we can say the total length 5 cm minus 1.4 minus 1.4, which is equal to 5 minus 2.8 equal to 2.2 cm. To find the volume of one gulab jamun, that is volume of the cylinder plus 2 times volume of the hemisphere. Substituting the formula, it will be 2 times 2 by 3 pi r cube plus pi r square h. Taking the common factor pi r square, we have pi r square into 4 by 3 r plus h. Radius is equal to 1.4, height is equal to 2.2. Substituting the values, 22 by 7 into 1.4 whole square multiplied with 4 into 1.4 by 3 plus 2.2, we have 22 by 7 into 1.4 into 1.4 multiplied with 5.6 by 3 plus 2.2. Finding LCM and reducing into the lowest term, we can see it will be 22 into 0.2 into 1.4 multiplied with 12.2 by 3, which is equal to 75.152 by 3 centimeter cube. Therefore, volume of 45 gulab jamuns will be 45 into 75.152 by 3, which is equal to 1127.28. We are given the syrup inside a gulab jamun is 30% of its volume. So, volume of the syrup is equal to 30% of 1127.28, which is 338.184, which is approximately equal to 338 centimeter cube. Question number 5. A vessel is in the form of an inverted cone. Its height is 8 cm and radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. We are given a cone with radius 5 cm and height 8 cm, and it is given it is filled with water up to the brim. Let us find the volume of the cone, that is 1 by 3 pi r square h equal to 1 by 3 into 22 by 7 into 5 square into 8. As it is given, when lead shots are dropped into the vessel, 1/4 of the water flows out. Let us find how much of the water flows out. Volume of the water flows out is equal to 1 by 4 of volume of the cone, which is 1 by 4 into 1 by 3 into 22 by 7 into 5 square into 8. Here the lead shot is in the shape of a sphere of radius 0.5 centimeter. Let us find the volume of a lead shot, which is 4 by 3 pi r cube, which is equal to 4 by 3 into 22 by 7 into 0.5 cube. Let us find the number of lead shots dropped in the vessel. So for that, let the number of lead shots be n, and we can say number of lead shots into volume of a lead shot is equal to volume of the water flows out. Substituting the values, n into 4 by 3 into 22 by 7 into 0.5 cube is equal to 1 by 4 into 1 by 3 into 22 by 7 into 25 into 8, cancelling the values of pi and the denominator 3, and we can find n is equal to 100. That is, number of lead shots dropped in the vessel is 100. Question number 6. A solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram of mass. Here we can see the shape is a small cylinder surmounted on the top of a bigger one. The bigger one, height of the cylinder is given 220 cm and the diameter is given 24 cm. Therefore, we can write diameter of the first cylinder equal to 24 cm. Therefore, radius of the first cylinder is 12 cm. Also, height of the first cylinder is given as 220 cm. Now, for the second cylinder, height is given as 60 cm and radius is 8 cm. Therefore, we can write radius of second cylinder 8 cm, height of the second cylinder 60 cm. To find the mass of the pole, we need to find the volume of the solid shape. Volume of the pole will be volume of the first cylinder plus volume of the second cylinder. Being radius and height different, we can use capital R and capital H for the first cylinder and small r and small h for the second cylinder. That is pi r square h plus pi small r square h. Taking pi as common, and it is given in the question, we should use the value of pi as 3.14. So it will be 3.14 multiplied with 12 into 12 into 220 plus 8 into 8 into 60, which will give you 3.14 into 31,680 plus 3,840, which is equal to 3.14 multiplied with 35,520, and the answer is 1,11,532.8 centimeter cube. We are not asked to find the volume, we are asked to find the mass. Mass of 1 centimeter cube of iron is 8 gram. Therefore, mass of 1,11,532.8 centimeter cube of iron will be 8 multiplied with 1,11,532.8, which is equal to 8,92,262.4 gram. Converting into kilogram, that means divide by 1000. We have 892.26 kilogram. Question number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 cm and its height is 180 cm. We are given the solid consists of a hemisphere and a cone. We are given the height and radius of the cone as 120 centimeter and 60 centimeter. As this cone is mounted on a hemisphere, we can see radius of the hemisphere is also 60 centimeter. To find the volume of the solid, we can say it will be volume of the hemisphere plus volume of the cone. That is 1 by 3 pi r square h plus 2 by 3 pi r cube. Taking 1 by 3 pi r square as common, it will be 1 by 3 pi r square into h plus 2r. Substituting h as 120 and r as 60, we have the answer as 9,05,142.86 centimeter cube. Now it is given that the solid is kept inside a cylinder which contains full of water. So let us find the volume of the cylinder. That is, here cylinder is given radius equal to 60 and height is equal to 180. Volume of the cylinder pi r square h is equal to 22 by 7 multiplied with 60 into 60 into 180, which gives 20,36,571.428 centimeter cube. To find volume of water left in the cylinder, we can say it will be volume of the cylinder minus volume of the solid, which is equal to 20,36,571.428 minus 9,05,142.86, which is equal to 11,31,428.568 centimeter cube. When we can write it as meter cube, it will be 1.131 meter cube.